Hi folks, we're going to carry on. We're going to talk about stroke sanders and wide belt sanders here now. Just a thought before I actually go into that, one thing that I overlooked when I was talking about the sandpaper and stuff, and that is the effect of moisture on these sanding belts. If your paper belts happen to start picking up moisture, and you're going to pick up moisture based on the humidity in the air, those belts will start to deform. In a case like this, if it's a paper belt, if it starts picking up moisture certain times of the year, it will do that. That belt is going to start to bend like that, and it'll do that right on the wide belts or on the stroke sanders. And what that does is that when you apply pressure on that sanding belt, what you're doing is you're making contact with the outside edge of the belt first to the surface. You're not actually getting even wear out of that belt. So it is actually an issue with performance of the belt, how long the belt's going to last, increased risk of tearing the belt and damaging the belt. You get the same issue in the fall when you first turn the heat on in your facility. We see it a lot in the shop about early October when management turns the furnace on. In our workshop, that's cool. The air gets really dry and you'll see wood panels will start to work, but it also has an impact on your sanding belts. And when that happens, those sanding belts start to turn this way. They actually start curling up. So the paper on the back side starts to dry, starts pulling on the belt, and it causes it to start to bend up a little bit like that. That's a little extreme, but that's kind of the idea of what's happening. And that has the similar effect as far as wear and lifespan and so on of the belts. So to control that, in our facility we have a special room at the back of the shop near the maintenance department, and that's a humidified room, and so we keep the belts at a fairly consistent moisture temperature or moisture content. So we minimize the effect or the damage on the belts that way. So that's something to think about. And if moisture is a major problem in your facility and you have difficulty controlling it, a lot of companies will go to a polyester backing on their belts. They're going to pay a lot more for those belts, but the polyester belts or the cloth belts are moisture resistant, so it doesn't have any impact on them at all. This particular belt here is an aluminum oxide belt, which is probably the most common woodworking sanding belt that's available. Aluminum oxide used in a lot of industries, but in terms of durability and quality, that's about as good as what you need. If you're sanding a lot of particle board and MDF, abrasive materials, you may have to step up to a better quality belt, and that would be a silicone carbide surface. And when that happens, you get a lot more life out of the belt. It's a lot more durable. The grits don't wear out quite as fast. However, you're going to pay a whole lot of money for more money for those belts as well. So something to think about if you're interested in purchasing belts. The slideshow that I have on the board right now is just going to show you some of the various pieces of equipment. Here I've got a couple of stroke sanders, and they're not unlike what we have in the shop. The one on the top on the left and the one on the right is it's a combination unit. It allows you to reduce and increase the tension on that sanding belt with a little bit more accuracy. And machines like that are often used for profile sanding, where you can add a little bit more flex into the belt by having the idler wheel up higher up like that. So maybe we can forward that, Laurie. These are specialty stroke sanders. The one on the left is a double head sander, and it has the ability to put a rough grit and a finished grit on the machine at the same time. It's just a method of speeding up the sanding process. So rather than loading a panel, putting a belt on to do your rough sanding, and then putting a new belt on this machine, you could put two belts on at the same time. There's two different sanding heads on it, and you can choose the rough sanding belt, and then right away you can grab the finished sanding belt, and you can do both operations at the same time. I threw the other one on there, just more of an interest thing. That was a custom built mold. That's actually, it's a casket lid sander on a stroke sander. And it rotates around in a circle, so it's just ways that you can modify the machines to suit a special need. Now, everybody should be familiar with this machine. This is our wide belt sander, used for solid and for veneers. And Laurie, if we move forward one more, this is a schematic of what or a rough diagram of what the interior looks like. And if I could just grab a pointer stick here. Sorry about that. This would be the leading head going into the machine. This is for it's what they call a sizing head. And it's used for cutting the panel to a specific thickness. The one at the back is your polishing head and your polishing pad. Those are what you're going to use if you're sanding veneers. We can move forward, Laurie. And everybody should be familiar with this one. This is the home screen for all the loading of information. And it's pretty much consistent with what we're using in the shop, although we have difficulty maintaining the categories in our shop because there's so many people using it. And move forward. So this is the screen that I really want to get to, and this tells you a lot of information. And I know a lot of you are working with this machine on a regular basis, but some of you may not be familiar. So on here, this tells you which heads are on. If the head is turned on in the black, that means that head is operating. And we also have other information on here. We have the grit size on the front head, the grit size on the second head, and the pad itself on this one is not actually running. This tells you the thickness of, this tells you where you're at, this tells you where you want to go as far as moving the thickness. And you can do it with the computer, or you can do it manually just by adjusting the plus and the minus over here. And down at the bottom is your feed speed for the travel time on the table. You can move forward there, Laurie. And we'll just, that's a bad picture, so we'll just keep going. Okay, so this, if you open up the second sanding head, this is an internal picture of what's going on that machine. This is a little bit different setup. This shows you that we have a sanding pad that's activated. This is a timing device, and this actually measures in cycles per second. It's not an actual measurement of 20 millimeters or minus 25, it's cycles per second. There's a timing device built into the machine, and that controls when the heads come down and when the heads come off. And we can also control the pressure. Here we have an adjustment. We're running at 0.5 bar on this layout right now, and 0.5 bar represents about 7.5 pounds of air. And then finally we have how many pressure pads we have connected to this setup. So I think we're getting low on time here, so we're going to stop here and maybe start on the next video.